So, good morning friends, how are you? Everyone is fine? Okay. 3 questions. You have to ask yourself 3 questions. Where are you now? Where you want to be? And how you will go there? 3 क्वेश्चन आपको अपने आप से पूछने हैं. अभी कहाँ हो, जाना कहाँ है और कैसे जाओगे. These 3 questions will give you the clarity. So now we were continuing the design of 3-phase induction motor. Now the next topic is choice of power factor and efficiency. So C naught is equals to 11B average kW eta cos theta into 10 to the power minus 3. So now the value of power factor and efficiency under full load conditions are higher. Once again I am repeating, values of power factor and efficiency under full load conditions are higher for higher rating machine, for high speed machine. Now increasing the speed, we cannot increase the speed of the machine beyond a certain limit, because higher centrifugal forces may damage the rotating parts, and there may be large frictional loss can also be there. So 2 things, high centrifugal force may damage the rotating parts and large frictional losses can occur. Now separating the D and L. So output equation Q equal to C naught D square L N S. After estimating the value of C naught and having knowledge of its speed Ns, D square L equals to Q by C naught into Ns. We need a second equation between D and L. Separating the D and L, the second equation is derived from the value of ratio L by tau. Tau is pi D by P is the pole pitch, you can say. In this way you can separate or just take out the relation between D and L. So separating D and L, choice of the ratio, you can say L by tau. So ratio, if L by tau will be between 1.5 to 2.0, the feature you can say minimum cost, when the ratio should be 1.5 to 2.0. Good power factor is considered 1.0 to 1.3, when good power factor ratio will be L by tau. When the ratio will be 1.04 to 1.6, so good efficiency, for good efficiency ratio should be 1.4 to 1.6, best power factor tau root under 0.18 L. So we can say good overall design, in that the ratio of L by tau will be 1.0 to 1.1. So you can calculate the value of D and L also separately, and you can calculate easily the ratio of L by tau. For diameter D, peripheral speed should be below 30 meter per second. Only for a specially designed machine it can go up to 60 meter per second. Once again I am repeating, for diameter D, peripheral speed should be below 30 meter per second. Only for a specially designed machine it can go up to 60 meter per second. That is V. We all know that V equals to omega R, and we can write that 2 pi ns into d by 2, r radius diameter by 2. So it will become pi d ns. It will become pi d ns. Now another checkpoint you can say for length L. If the length of armature stator is more than 10 to 12 cm, if the length of armature stator is more than 10 to 12 cm, dust must be provided to enhance the cooling. Ducts must be provided to enhance the cooling. Each duct is having the width of 8 to 10 mm width. Each duct is having width of 8 to 10 mm. These all are the checkpoints. So if I will tell you that One assignment is there. Find the main dimension of 15 kilowatt 3 phase 400 volt 50 Hz 2810 rpm squirrel cage induction motor having an efficiency of 88% and a full load power factor of 0.9. Assume a specific magnetic loading 0.5 Weber per meter square and a specific electric loading 25,000 amp per meter. Take rotor peripheral speed as approximately 20 meter per second at synchronous speed. So Q equals to C naught into D square LNS. C naught equals to 11 BAV AC into kW eta cos theta into 10 to the power minus 3. So we have been given these values. Output equals to 15 kilowatt. Efficiency is 88%. Power factor is 0.9. B average is 0.5. That is magnetic loading is 0.5. AC is 25,000. Electric loading is 25,000. And take kW equals to 0.955. So you can calculate the C naught by the formula of 11 into BAV AC kW eta cos theta into 10 to the minus 3. Now we will proceed again and Q equals to C naught into D square LNS. So we can calculate D square L, as we know that small ns equals to capital Ns by 60. So it will come to 50, 3000 by 60 equals to 50, and 15 equals to 104 into D square L into 50. That means D square L will be 2.88 into 10 to the minus 3. This is the first equation, you can say. Now what is the second equation? Second equation, peripheral speed we have given 20 meter per second at synchronous speed. So V equals to omega R. V equals to omega R. Omega equals to 2 pi ns and R equals to D by 2. So we will get the value equals to V equals to 20. So pi D into 50 equals to 20 and D equals to 0.127 meter. Now D square L equals to 2.88 into 10 power minus 3. We will put this value in this equation and we will get L equals to 179 mm. We can get L equals to 179 mm. Now you can try the second question. Find the main dimension of 15 kilowatt 3 phase 440 volt 4 pole 1425 rpm squirrel cage induction motor having an efficiency of 90% and full load power factor of 0.88. In the question, assume a specific magnetic loading equals to 0.48 Weber per meter square and a specific electric loading equals to 25,000 ampere conductor per meter. Take rotor peripheral speed as approximately 25 meter per second at synchronous speed.